Okay, we're going to solve number 2 in the worksheet that I had given you. It says draw a free body diagram of the truss and solve for all the external and internal forces. I've already started this to get us going a little bit. We have to get the directions of everything, tell if it's a compression or tension, and then of course we're showing all work. Okay, so this is joint D. Didn't say that, and there's a 500-pound load right here. So of course I solved to see if it was statically determinate. They're all going to be at this point really for you, but we did that anyway. So there are 4 joints. There's 5 members that we counted, 1, 2, 3, 4, and 5, and 3 reaction forces, 2 on the pin and 1 on the roller. So 8 equals 8, so we're all good. Again, step 2, I'm just drawing the free body diagram. I've already drawn it. There's 2 reaction forces on the pin, one that's perpendicular, one that's parallel to the surface, and there's one on the roller that is perpendicular to the surface, which is horizontal. And then there's the 500-pound load. We had to find the distances. They told us this was 3 feet. Since it's a 45, 45, 90 triangle, this is also 3 feet. And because this is 60 degrees over here, if you put that in, use the tangent function, or use your 30, 60, 90 rules, then this is 1.73. I just rounded it to 1.7. Okay, so now we need to solve for these forces. So first we're going to start with the sum of the moments. We're going to sum the moments around point A, because that's where the pin is. Has to equal 0. That gets rid of those 2 forces. So we only have 2 forces left. We have the load times the distance to the load. Okay, and then we also have reaction force B in the y direction times the distance to By. This one here is going to cause me to go around clockwise. The load will cause me to go clockwise, so it's going to be a negative, and the RBY will cause me to go counterclockwise, which is a positive. So this says RBY times the distance to By is equal to the load times its distance to the load. We're looking for RBY, so if we divide both sides by the distance, we'll go over there, the distance By over here, and the load is 500 pounds. The distance to the load was 1.7, and the distance all the way across was 4.7, because we have to add those 2 things together, the 3 and the 1.7, to get 4.7 all the way across from my pivot point. That will be RBY. And now we know that 500 times 1.7 is that, and then we're going to divide that by the, what do I have, 4.7. We get 180.85. I'm just going to round everything off to make it easy on us today. So we're going to call that 181. So RBY is 181 pounds. Okay, we got a positive answer, so I must have guessed right. So this is 181 pounds. And we've got that guy done. Now we have to solve for these 2 over here. So we're going to use the sum of the forces in the x is equal to 0. In the x direction, I just have RAX. That's the only thing I have in the R. So done. That was easy. So this is 0. Okay, so he really kind of just goes away. It's not really even there. We're going to leave him there, kind of show that he's 0, but there's really nothing going on. And then we're also going to do the sum of the forces in the y, also 0. Now there's a lot going on in the y. We have RAY, which we said is going up. We have the load, which we says is going down, so that's going to be a negative. And then we just determined that RBY is also going up, so he's a positive. And we know that for sure. And we're solving for RAY. Move the other 2 things to the other side. So we're going to add the L, subtract RBY. So we're going to have negative 500 pounds. And then we're going to add the 181 pounds that we found for RBY. And we get that RAY, the reaction force, pin A in the vertical direction is, sorry, got these backwards. Like I said, plus and minus, but I don't know why I put them in there. So we have a plus and a minus. So I have the 500 pounds and the minus the 181. Not sure what's going on here. 500 minus the 181. Why should it be different on video than I am in class, right? I always goof those things up in class, but at least we catch our mistakes. We get 319 pounds. And we got positive as well, so the direction must be good. So this is 319 pounds headed up. And that is it. We have solved for all the external reaction forces. So back on our paper here, we can say that RAX was equal to 0. RAY was equal to 319 pounds. And RBY was equal to 181 pounds. And again, if you didn't round off, you'll be off by a few decimal points. RAX, it's not going anywhere, right? Because there's no direction, so we don't have to put any kind of arrows in for that. RAY we thought was going up, and RBY also going up. All right, so now we want to solve all the internal forces. So we're moving on to internal, so it'd be step 3 on the little notes we took. For the internal, we're going to redraw the free body diagram. So we're going to have point C, this is going to be point A, this is going to be point D, and then out here we're going to have point B. And then we're going to put all those together. Like so. And then we have the external forces, which we know. This guy's going this way. This is RBY, which was 181 pounds. And then this is RAY, which is 319 pounds. We had the load going down here, which was 500 pounds. And then inside here, these are where we're trying to find all these forces. So we're trying to find force AC. We're trying to find force CD. We're trying to find force BC, force BD, and force AD. So we want to find those 5 things in green. They gave us some angles. They said this was 60 degrees. We know this was 90, so this has to be 30. Okay, we knew this over here was 45 degrees, because they told us back in the original. That was 45, and if this is 90, that means this up here also has to be 45 degrees. Okay, and that's really all the forces that we have on our problem here. And so now we need to go solve, so we have to look for the easiest joint, so the most unknowns. Oh, we forgot to put everybody in tension, didn't we? Go put your arrowheads on there. Everybody's in tension. That means the arrows are pointing away from. Okay, and now we can go look for which is the easiest one. Oh, it would help if I put that where you can see it. Okay, so we got all up. So we're trying to find the forces in green, our reaction forces we solved for. Remember, this one was 0 in the A direction, so we're just leaving it off. Our load was 500, and then we put all our forces in tension with the angles. Okay, so this one has 2 unknowns and 1 known with 1 angle. This has basically all 3 unknown with 2 angles, so that's awful. We're not going to start with C. B has 2 unknowns with 1 known. And D has 3 unknowns, 1 known, no angles. So I like D, but it's just 3 unknowns, so we just really can't do it. So we have to go one of these that has 2 unknowns. So A or B, it really doesn't matter. We're going to end up with the same thing. Okay, so let's just start with A because it's A, right? A is the first thing. So I'm just going to redraw A so I can just try to keep my paper together here. Keep you all on the screen. Okay, so there we know that. We know that we have RAY coming up here, 319 pounds. We know we're looking for force AC and force AD are the 2 things we are looking for. Okay, so now let's just go to this paper by itself. All right, so we know things in the Y direction. So we're going to start in the Y direction. Some of the forces in the Y, it must be 0. Anytime we have something going off at an angle, we want to break that thing into its 2 components. So we're going to take this top one. We're going to break him up into force AC in the Y. And this guy over here is force AC in the X. Okay, we know things in the Y, so let's start in the Y, like we said over here. So we know we have force AC Y headed up, and we know we have RAY also going up. We're looking for the force ACY, kind of. It's the only thing in the vertical we know to help us find force AC. So force ACY is going to be equal to negative RAY, which is equal to negative 319 pounds. So that's great. We found that. That was super easy. But we don't want ACY. We want force AC. So we need to go look at this because we also know that force ACY, because of my trig functions, and I have a triangle here, it's going to be the hypotenuse, force AC, what we're looking for. Okay, and then that times, it's the side opposite. Side opposite goes with the sine of the angle. We're looking for force AC, so we're going to solve for him. Force AC is equal to force ACY, which we know that number, divided by the sine of the angle. So that's going to be negative 319 pounds divided by the sine of 60 degrees, because we know that's 60 degrees there. And this is going to let us solve for force AC. So we go with negative 319 divided by the sine of 60. And we get negative 368. Negative 368 pounds. So the negative tells me I have to flip everybody. Everybody's going to go the opposite direction. Okay, we do know that it's 368 pounds. We know that much. Then you got to flip these too. Right? They're not going this way. It's not going that way. They're going that way because my arrow, the vector is going down to the left. So we have to have down and to the left. Okay, we do that before we solve the sum of the forces in the x direction. It's also 0. In the x direction, we have force AD. Okay, and that's going to the right, so it's positive, minus force AC in the x direction. So this tells me that force AD, what I'm looking for, is equal to force AC in the x direction. Okay, we don't know all those things. We're going to find force AC in the x direction, but we know force AC. Okay, so force AC in the x direction is equal to the hypotenuse, force AC, which we just solved for, times its side adjacent, so times the cosine of the angle. So this is going to be 368 times the cosine of 60. Let me take this, 368 times the cosine of 60. And we get that it's 184. So force AC is 184 pounds. Okay, I'm sorry, force ACX is 184 pounds. So we can go back and put that in here. That means force AD is 184 pounds. We just solved for force AD. And it was positive, so nothing changed. It is going to the right. Okay, so I'm going to go back to my original picture, and I'm going to put all those numbers in that I just found. So force AC right here, I just found was 368 pounds. And we know that it is, the arrows switched. We got to go switch all my arrows here. The arrows are going this way. Arrows are pointing towards the dots. That means I'm in compression. So I'm going to put a little C here. Tell me that's in compression. And then force AD, I just solved for him. He was 184 pounds. And we didn't switch the arrows. They stayed in tension. So 184 pounds. I didn't make my picture big enough, did I? In tension. Okay, so we got 2 done. We got 3 to go. So we're going to keep going. So now we look at the next easiest joint. So if I look across here, I got these 3. I know 2 things about this one. So 2 unknowns and no angles, 2 unknowns and 1 angle. Let's go with joint D because he looks easy. C was the awful one. We'll probably never touch C. Okay, so this was joint A, right? So let's go to joint D. So I'm going to redraw D here. I know it had these forces going like that. I know it had the load. I'm going to go back. The load was 500. Okay, so the load equals that. I knew that this guy, force AD, was 184. So force AD is equal to 184 pounds. And that's all I know. This is force CD, and this is force BD. Okay, and I know all these things are 90 degrees, so that makes my life easy. This one, I know something in the Y, I know something in the X, so it doesn't really matter what I start with, so let's just start in the X because it comes first in the alphabet. So the sum of the forces in the X is equal to 0. In the X direction, I have force AD going to the left. Okay, so I'm going to have a negative force AD, and then I have force BD going to the right, plus force BD going to the right. So this tells me that force BD is equal to force AD, which was equal to 184 pounds. So that's done. All right, we solved that. This guy right here, also 184 pounds. And we got a positive, so the arrows stay the same. So we're all good. Okay, so let's go to the sum of the forces in the Y. See how we like the ones with no angles. Okay, in the Y direction, we have force CD going up. We have the load going down. So this tells me that the force CD is equal to the load. The load was just 500 pounds. So force CD, done. 500 pounds. Again, everybody's positive, so all the arrows stay the same. We're all in tension. So let's go fill out our little paper here again. Okay, so we found force CD was 500. And he stays in tension. We found force BD, put this on the paper so you can see it, was also 184 pounds, and he was also in tension. So now we found 4 out of the 5. We got to find force BC. Well, we got joint C or joint B. We got to pick which one we want to go. This one's going to be easier because there's only two unknowns. Actually, there's only one unknown, right? Because we just solved for force BD. So we know this side, that side. There's one unknown and one angle. So we're going to go with joint B. Okay, so let's redraw joint B on here. Okay, so if we draw B, he's headed off this way and that way. And then we have this guy coming. This was resistance force B in the Y direction, which was 181 pounds. This over here was force BD, which was 184 pounds. And then force BC, going up this way, this is what we're trying to find. That's my only unknown at this point. Okay, and we also knew that this was 45 degrees. Okay, so now we got to solve. So we can start sum of the forces in the X and the Y, because we know an X and we know a Y. So it doesn't matter, pick your favorite. Either way, we're going to have to solve a triangle. Doesn't really matter. So let's do sum of the forces in the Y. I don't know. Okay, it's equal to 0 in the Y direction. And again, we got to break apart this triangle. I'm going to draw him up here above just so he stays out. Okay, since 45 is easy, we know this is 45 over here as well. Okay, if we draw him in here, then it keeps the 45. We'll end up with the same stuff. It doesn't really matter. But this way allows me to show you my numbers easier because I'm not stuck inside there. So this is force BC in the Y. This is force BC in the X. So I can write an X. Okay, that's 45 there. And now if we're doing the sum of the forces in the Y, we're going to have force BCY going up. And then we're going to have reaction force BY also going up. So we're going to add him. Those are the only two things going vertically. So we're done there. We're looking for BCY to get to BC. So we can say that force BCY is equal to negative reaction force BY, which is equal to negative 181 pounds. Okay, we also know that force BCY, because of our trig functions, is equal to the hypotenuse, force BC, what we're looking for, right? Remember this guy we're looking for, times, and force BCY is the side adjacent to this 45, because we're dealing with the pink triangle right now, so it's adjacent, so it's going to be times the cosine of 45, or the angle, but it will be 45 in a minute. And then force BC is what we're solving for. Okay, so if we want to rearrange this and say that force BC is equal to force BCY over the cosine of that angle, which is 45. And BCY, we said, was negative 181 pounds over the cosine of 45 degrees. So we're going to go negative 181 divided by the cosine of 45. And we're going to get 255.97, so we're going to go negative 256 pounds. And the negative tells me that my value, right, my magnitude is 256 pounds. The negative told me the arrows are going to switch. That means all the arrows on my pink would switch. It doesn't really matter because I'm kind of done with the pink because I don't need to do the rest. I'm done solving all my forces now. So now I can go back to this guy and I can switch and say that this guy was 256 pounds. We switch the arrows, which means we're in compression. So we got to go switch the arrows. That guy switches from there to there. That guy switches from there to there. So the two outside ones are in compression. The three internal ones here are in tension. And that is done. So let's get all this out of the way and zoom in here a little bit so you can see the final answer. Because we've got to go write those things down, don't we? Okay, let's see if we can get all this on the screen at one time. I'm going to have to zoom back out. Do all the zooming, just unzoom. Okay, so we said that force AD, we said was 184. They're all pounds, okay? So all these are pounds. I can write pounds in there. And then force AC, which is up here, we said was 368. I can remember I rounded off. And then force BC was 256. So if you left decimals, you're going to be off just a tiny bit from me. Force CD, which is the one in the middle here, was 500. Force BD, which is the one over here, I had 184. And then, let's see, force AD was in tension. Force AC was in compression. Force BC was in compression. Force CD was in tension, and force BD was in tension. Look at that. How easy today. We can sit here and sing our song. Okay, there's all your answers for number 2. Aren't trusses fun? Yes, they are. Okay. Have fun with yours.